In this section, you're going to have the definition of derivative. This is we're going back over our quotient rule that we talked about in our first chapter. So this is just an expansion of the quotient rule. So our first problem says use the definition to find the derivative. Now the actual derivative here is 4x minus 20. It's super easy, super fast to do when you get to the next section. But for this particular problem, since I asked you to use the definition, you must use the definition to get credit. So the definition of derivative says I'm going to take the limit as h goes to 0 of f of x plus h minus f of x all over h. Now we've done some of these before this semester. Alright, so I like to just come to the side and start. I'm going to first do this little piece right here, the f of x plus h. Okay, now this particular function is 2x squared minus 20x plus 5. Okay, that's what that function looks like. Now, what I'm going to do is you'll notice that there's an x plus h in parentheses. So that x plus h is what goes in the parentheses all the way across. That's what replaces the x. So coming to the side over here, I'm going to do my x plus h squared, FOIL it out. Okay, so when I FOIL this out, I get my 2 out in front, and then I get this FOILed part, x squared plus 2xh plus h squared, and then I can finish the rest. Okay, simplifying this out, just distributing through, we'll get 2x squared plus 4xh plus 2h squared minus 20x minus 20h plus 5. Right, nothing simplifies. So that's the end of step 1, and that completes that cloud that you see that I've circled at the top of the page. Okay, so what my next part is to do is I'll put it in green, is we're going to do the entire top. So it starts by saying f of x plus h. Well, that's what we just found in step 1. So that was actually going to be 2x squared plus 4xh plus 2h squared minus 20x minus 20h plus 5. Okay, that's what we found in step 1. After step 1, you're going to say subtract. That's where that comes from. And then you always say the original. So the original is 2x squared minus 20x plus 5. And this is what step 2 would look like. Now what we're going to do with this step 2 is subtract out. And you can do this part in your head. You see that you have a 2x squared here minus a 2x squared here. And you have a negative 20x here. 2 negatives make a positive 20x here. And you have a 5 here and a minus 5 here. So that's step 2. So what that's going to leave you with is 4xh plus 2h squared minus 20h. Now what step 3 tells you to do is divide by h. So we're going to divide all of those pieces by h. Now when you do that, you're going to get 4x plus 2 with 1h left over minus 20. Now I think in the My Math Lab homework for my online classes, they actually ask you this little part right here. It tells you to simplify that part. I think I also ask you that on the quiz for my online classes. I make you simplify it part of the way. So you might see this particular step on there. As soon as you get to this step, you're going to evaluate the limit. And you'll notice the limit is as h goes to 0. So as h goes to 0, that means I would be plugging in a 0 right here, and that piece would go to 0. That h does not affect the x. So my answer for this one would just be 4x minus 20. And that's the derivative of this expression, this function, using the definition. That's how it looks. X minus 20. Okay, so one of the things I want to point out is in the My Math Lab homework, I think they ask you this question. First of all, it asks you to find the derivative using the definition. Okay, so that's what we did there. And I believe that it also asks you to find the derivative at a point A. So if it asks you to find a derivative at a point A, all you're going to do is whatever that A value is, you're going to plug in for X. And so you can work on that with your My Math Lab homework for those of you in my online class. And look at that. It also has a help me solve this in a video for it. I'm not quite sure exactly how it asks, but I think you just take your A value and plug it in. And that's what you have with the definition.